Let's look at this experiment setup. We have a toy car that we're pushing with the exact same starting force across 3 different road materials, X, Y, and Z. We're going to measure exactly how far it travels in 10 seconds on each surface. What do you think the results will tell us? All right, let's look at our measurements. On material X, the car rolled 32 centimeters. On material Y, it went quite a bit further, 40 centimeters. But look at material Z. It only made it 28 centimeters. Why would the exact same push give us such different distances? Let's think about that. The key science concept here is friction. Think of friction as a resistance force. It's an opposing force that 2 surfaces apply to each other when they rub together. A rougher surface has tiny bumps that rub harder against the car's wheels, creating more friction and slowing the car down quickly. Smoother surfaces? Well, they have less resistance, so the car glides much further. That's why we get different stopping distances on different roads. Now let's test our knowledge. Here's our first question. What forces are actually acting on the car while it's in motion? Take a look at the options and try to break it down. Spot on! The key forces acting on our moving car are indeed friction, resisting its forward motion, and gravity pulling it downward. While gravity keeps the wheels firmly on the road, it's the varying friction of each material that actually changes how quickly the car slows down. All right, here's an engineering challenge for you. If you were building a road right outside a school, which of these materials would be the safest choice? Think about stopping distances. Exactly, material Z is our safest choice. Since its rough surface creates the highest friction, the car stopped in the shortest distance. If a child suddenly steps onto the road near a school, having a high friction road means a real car can brake and stop much faster, preventing accidents. What happens if it starts raining? Let's think. How would pouring the same amount of water onto each surface affect how far our toy car travels? Make your prediction. That's it. Water acts as a lubricant. It fills in the microscopic rough bumps and grooves of the materials, making the interaction much smoother. This lowers the friction on all three surfaces. With less resistance, the car glides further on each material, which is why stopping distances increase so much on wet roads. Let's wrap up what we've learned. First, our moving car is always influenced by two main forces: downward gravity and opposing friction. Second, rough surfaces like Material Z have higher friction, which is crucial for safety zones near schools to keep stopping distances short. And finally, wet surfaces have lower friction because water acts as a lubricant, making roads slicker. Keep these principles in mind next time you answer these OEQs.